Hello everyone, good evening. I just thought I'll record a video for our 7th standard students. So I thought I'll do some maths with them. So this is the first chapter, integers. So let's check out the meaning first, what integers mean. So basically integers will consist of three things. Number one, the negatives of all natural numbers, something like -1, -2, -3, and it goes on up to infinity. It includes a 0 as well, and then all the positive numbers, the positive natural numbers, in fact, 1, 2, 3, 4 up to infinity. So in a nutshell, we show it as integers is represented with the term I, capital I. So if we have to represent the integers, we show it like this. So 0 comes in between, and all the natural numbers towards the left side of the 0 indicate the the negative integers, and all the natural numbers towards the right side of the 0 indicate positive integers. So we could say it as the integers consists of all the positive natural numbers, a 0, and all the negative natural numbers. Now let's check out the multiplication of integers. The product of two integers of the same sign is always positive. I repeat this. The product of two integers of the same sign is always positive. For example, let's see. We have a positive sign, any positive natural number, into another positive natural number gives you a positive integer, a positive product. Similarly, you check out the sign. The signs are same. So we have a plus here and we have a plus here. So two numbers with the same sign yield the same positive integer. Then any two numbers with the negative sign again yields the same positive integer. That means the product of two integers of the same sign. So the emphasis here is on the signs. They yield the same. The result or the product is always a positive number. For example, we have plus 5 into plus 4 gives you plus 20. Similarly, if I take minus 5 into minus 4, I get plus 20, because minus into minus gives me plus. Plus into plus gives me plus. Let's go to the other one. The product of one positive integer and one negative integer is always negative. Now this is the ruling, the multiplication ruling. We all know this very well. Example, one positive integer into one negative integer gives me a negative integer. Similarly, one negative integer multiplied with a positive integer gives me a negative integer. For example, let's use the same numbers. So I have here one positive integer plus 5. When I multiply it with minus 4, which is a negative integer, now let's check out the product here. So plus 5 into minus 4 gives me the product as minus 20. So the integer here becomes a negative integer, because the signs here are, one is a positive sign, the other one is a negative sign. So either positive or negative gives you negative, or a negative or a positive gives you negative. Similarly, if I take minus 5 and plus 4, if I multiply these both, I still get it's minus into plus equals minus 5 fours are 20. So in a nut, let's quickly brush it up. So it says plus into plus gives you plus. The two integers with the same sign yield you the same sign. Similarly, minus into minus equals plus. Again, the two integers with the same sign will give you a positive integer. One positive and one negative gives you a negative integer. One negative and one positive gives you a negative integer again. Now let's check out the properties. Now let's check out the different properties of multiplication of integers. First is the closure property. Then next is the commutative property. Then we have the associative property. Then we have the distributive property. Then we have the existence of multiplicative identity. The last one is existence of multiplicative inverse. Let's check these things out in detail. Let's go to the first property, which is the closure property. These are all the properties of multiplication of integers. Now let's try and understand this closure property. So the multiplication of two integers under this property always gives you an integer. Let's say, for example, m and n are two integers. So if these are the two integers, we express it like this: m into n gives you mn, according to the closure property of multiplication. Let's use this with some examples. So let's substitute the value of m with 5, and let's substitute the value of n with 6. So I can write it as 5 into 6 gives me 5 6 are 30. The product of 5 into 6 gives me 30. So 30 is also an integer. So we have 5 is an integer, 6 is also an integer, and the product of 5 into 6 is also an integer. Similarly, if I substitute the value of m, let's say if I'm substituting it to be 8, and I'll substitute the value of n to be let's say minus 12. So I have one integer which is a positive integer, and the other integer which is a negative integer. So let me take the values m into n. So m is 8 into n is minus 12. Okay, it has to give me mn. So that way, so first let's multiply the signs. Plus into minus gives me minus, and 8 into 12 gives me 96. So 8 12s are 96. So this is a negative integer, but still it is an integer. Let's go to the second property, which is the commutative property. Commutative property of multiplication of integers. So according to the commutative property, we have a little formula here. We have to remember this. M into n equals n into m. So this we have to remember. M into n equals n into m. So let's use the same above example. So what was the value of m here? I took the value of m to be 5. Then I took the value of n to be 6. Let's use the same examples. So m, let's substitute m with 5. And let's substitute n with 6. So I still get the same thing. The value of n is 6 and the value of m is 5. I'm using the same example here, above example. The value of m I had earlier taken it as m, and the value of n I had taken it as 6. So I'm using the same example, same values here. M I'm substituting with the value of 5, and n I'm substituting with the value of 6. So m into n yields me the same result. I just have to reverse it, n into m. So that is 5 into 6 equals 6 into 5. Let's check out the result. 5 6 gives me 30. 6 5 also gives me 30. So 30 equals 30. So the result of two positive integers is also a positive number. Even if I reverse the numbers, even if I reverse m into n as n into m, I still get the same answer. So this is basically a commutative property of integers. Let's try and use the other numbers which I had used earlier, like 1 positive and 1 negative. So 8. So let's now substitute the value of m to be 8 and the value of n to be minus 12. So let's check out the example now. So according to the commutative property, m into n is equal to n into m. So the value of m is 8 and the value of n is minus 12. So here it has to be equal to, the value of n is minus 12 into 8. Now still it gives me the same value. 12 8s are 96, plus into minus is minus, so I get minus 96. Minus into plus is plus. 12 8s are 96. Any number with I just have 8 here, so we have to take it as plus 8. We have to assume it to be plus 8, not necessarily that we have to show the sign as plus. We can assume it to be plus 8. So plus into minus is minus. First let's multiply the signs in case if we have a positive integer and a negative integer. First multiply the signs. So plus into minus gives you minus, then multiply the number. 8 into 12 gives you 96. Similarly, minus into plus gives you plus, and 12 8s are 96. So here the number, here it needs to be minus because plus into minus is minus. So the values are same. Minus 96 equals minus 96. So now let's check out the third property of integers, which is the associative property. The third property, which is the associative property. Associative property of integers. Now according to the associative properties, property of integers, we have to take three integers here. Let's say we'll take L, we'll take M, and we'll take n. So let's just take these three integers. We have to take three. As in the earlier case, we took two alphabets. We took two numbers, two integers. Here we have to take three integers. So we have to now, we have a formula for this associative property, and we have to express it like this. It's L into M into n. Put the bracket for the second set of two numbers, equals L into m into n. Now put the bracket for the first set of two numbers. It's the same thing. L into m into n. Put the bracket here. L equals L into m into n, and give the bracket here for the first two integers. Now let's substitute the values. So let's take, for example, L to be, let's consider L to be 5. Let's consider m to be 3, and let's consider n to be 2. So if you're using with this formula, so L into m into n equals L into m into n. So the value of L is 5 into value of m is 3 into, and the value of n is 2. So let's put the bracket here for the second two numbers. And the value of L is 5, value of m is 3, and the value of n is 2. Let's put the bracket for the first two set of numbers. So write 5 as it is, into, multiply the two numbers which are given in the bracket. 3 2s are 6, equals, multiply the two numbers which are given in the bracket. 5 3s are 15, and then into 2. So 5 6 gives you 30, equals 15 2s also gives you 30. So the associative property of multiplication of integers is also true. So let's check the same property using some mix-up of positive and negative numbers. So let's now take the value of L, M and N. Let's take the value of L to be, let's say, 8, value of M to be -5, and the value of N to be 4. I've changed the values. Now let's check the property. What does it say? It's L into M into N. Put the bracket for M and N equals L into M into N. Now put the bracket for the first two numbers, first two integers in fact. Now let's substitute the values. L is 8, M is -5, N is 4 equals, again, L is 8, M is -5, and N is 4. Let's put the bracket here for the first two integers. So write 8 as it is, carry the into sign also as it is. Now let's multiply the ones which are there in the bracket. So first let's begin with multiplication of signs. So minus into plus gives you minus, then 5 into 4 gives you 20. Okay, equals, again let's now begin with multiplying the signs, because we have a positive sign and a negative sign. So multiply plus into minus gives you minus 8 5s are 40, and now into this 4. So again, first let's begin with multiplication. Let's simplify this. Plus into minus gives you minus 8 2s are 16. So the answer is 8 into 20 is 160 equals minus into plus is minus 4 4s are 16. So this property of association of multiplication of integers is also satisfied, and it is also true because it is yielding us the same result. Now let's go check with the other property, which is the distributive property, which is the fourth property, the distributive property of multiplication of integers. Multiplication of integers. Here, according to this property, if L, M and N are 3 integers, then L into M, now I have to write plus here. We wrote in the earlier associative property, we used the same three integers L, M and N, but we multiplied each one with another one. But here, now what we're going to do is, instead of we are multiplying L with M plus N. So L into M plus N equals, now see, I'll tell you how to do this. Take L and multiply it with M first. So it's L into M. Take this positive sign. Now again take L and then multiply it with N. So L into N. So it's L into M plus N. Just remember, in the earlier one we took it as L into M into N, but here we are taking it as L into M plus N, and then individually the integers which are given in the bracket, individually we are multiplying that with L. So the result will be L into M plus L into N. So this is how it looks. Now let's go ahead and check with the numbers. So now let's begin by giving some values. So let me see, I'm going to take the value of L to be 5, the value of M to be 7. I'm giving the value of 2 for the number for N. So let's now substitute it. So L into M plus N, put that in the bracket, equals L into M plus L into N. So the value of L is 5, the value of M is 7, and the value of N is 2, equals, so 5 into 7 plus 5 into 2. Now let's check it. Take this 5 as it is, take the into sign also as it is, add the number which is in the bracket. 7 plus 2 is 9. Let's multiply these two. 7 5s are 35 plus 5 2s are 10. So come back here, 5 9s are gives you 45 equals 35 plus 10 also gives you 45. Now the distributive property of integers has also proved to be true. Now let us check the same distributive property of integers with by using the subtraction sign, by using the negative sign. So we've used the positive sign here. Now the same formula, we're going to make a little change to it like this. Let me show you. So that this was basically the first one. This was the first one. Okay, under fourth property, let's say it is 1a, 4a, sorry, and this is 4b. So the three integers here are L, M, N, and the formula was L into, earlier it was M plus N, now it is M minus N. So that gives you, again, multiply L with M and then multiply L again with N. So it's going to be L into M. Now we have a minus sign here, so write the minus sign, then L into N. So L into M minus L into N. So the integers which are given inside the bracket, we are going to multiply each of the integers with the integer which is outside the bracket. And this time we have changed the sign from positive to negative just to test that the product that we get, the answer that we get, or the result that we get is true, or it satisfies the distributive property of multiplication of integers. So let's substitute the value of L, M, and N. Let us now take the values of L to be, let's say, let's take the same values, shall we? Earlier I had taken 5, 7 and 2. Let's take the same values now. So L, let's substitute it with 5, into M, let us substitute it with M is 7, and N to be once again L into M minus N. Okay, this is the question. So L into M is 7, N is 2. So I'm sorry, it has to be minus here. So L into M minus N. So the value of L is 5. The value of M is 7. We have a negative number here. Minus N is 2. Put that in the bracket. Equals L into M minus L into N. So L, the value of L is 5 into M is 7 minus, again L is 5 into N is 2. Now let's see this. Write 5 as it is, into sign also as it is. 7 minus 2 gives me how much? 5 equals 5 7s are 35. There's a minus sign here, carry that minus sign. Then 5 into 2 is 10. So 5 5s are, so I see that both the numbers that I have here are the positive numbers, positive integers. So 5 5s are 25. Let's see if I get the same number here. 35 minus 10 also gives me 25. That means the distributive property of multiplication is also suitable, and it is also true when we change the sign to the negative. It's called as the distributivity of multiplication over subtraction is also true. And the distributivity of multiplication, so the first one was the distributivity of multiplication over addition was also true. The second one was distributivity of multiplication over subtraction is also true. Now let's go to the next one, which is the fifth one, which is the existence of multiplicative identity. So here for every integer a, we have a into 1 will give you a, or 1 into a also gives you a. Now this is called as the existence of multiplicativity and identity. So for every integer a, we have a into 1 gives you a, and 1 into a also gives you a. So multiplication of every integer with a will always give you the integer a itself. Let's say for example, let's substitute the value of a as 5. So 5 into 1 gives you 5, 5 being a and 1 being 1. So 5 into 1 gives you 5, a itself, or 1 into 5 also gives you 5. So whether it is 5 into 1 or 1 into 5, anything multiplied with, any a multiplied with 1 always gives you a. Any number, number which is multiplied with 1 gives you the same number. Let's go to the next one, which is existence of multiplicative inverse. Here, for any integer a, its multiplicative inverse will be, for any integer a, its multiplicative inverse is going to be 1 by a, so that it can look like a into 1 by a, which gives you a, and a gets cancelled, which still gives you 1. So this is the multiplicative identity. Or let's use one example. So let's say for example, minus 1 into 1 divided by minus 1 always gives you 1 only, because minus 1 and minus 1 gets cancelled, and what remains is 1. Or if you're taking the positive numbers, let's say 1 into 1 divided by 1, so this number and this number gets cancelled, and what remains is just the inverse, which is 1. That's it for today. Thank you guys. Hope you must have followed. I'll make another video maybe with another chapter. Thank you and bye.